Properties of natural logs. Let b, x, and y be positive real numbers. B can't be 1. And let p be any real number. Then natural log of 1 is 0. Well, that goes with the old furry friend. Log base a of 1 is 0. We know that. Natural log of b is 1. That means log base. That's not true. That's not true. What letter should that be instead of B? E. Natural log, so log base E of E is 1. So they can't even do it right. I'm sorry. Natural log of e to the p is p. E to the natural log of x is x. These are called, by the way, and we didn't focus on them too much, these are called the inverse properties. And let's see kind of what that means. One thing I know for sure as to how the log and e operates. Here's my circles again. My college algebra says, oh no, not the circles, not again, anything but the circles, because that means domain and range. That what happens is that e to the x takes x's to y's. And natural log brings y's back to x's. They're inverses of each other. So that when they say natural log of e to the p, what they're saying is this is f inverse of f of p. Because remember, the logarithm brings it back, the function takes it across. Now, what do we know about the inverse and the function? What do they do? What do they do? Where do you always end up?
X.
Where you started. In this case, I started at P, I end up at P. Because F inverse and F cancel each other out. And if I have e to the natural log of x equals x is what they say. What this is f of f inverse of x. Exponential takes it over. I'm sorry, it's the other. And then logarithm brings it back. What happens to these two? They cancel each other out. It's the inverse property. Now, college algebra, you worry more about it there than we do here. We kind of ignore it. Now, these are the ones we know and love so well. Natural log of a product is a sum. Natural log of a quotient is a subtraction. And natural log of x to the p is p natural log of x. And yeah, we just saw that, right? It's as though that we have a completely different set of properties. The answer is no. But they do some disgusting things with all of this. So here we go. This is a quotient, and a quotient turns into a what? Subtraction. And 3x is a product, so a product turns into a addition. What happens here? The 2 comes down. Now, here's where they're sneaky, sneaky, sneaky. What's the natural log of E? What's the natural log of E? Remember, this is log base E of E. It's 1. Sneaky devils. So this is natural log of 3 plus natural log of x minus 2. Natural log of E is 1. What you'll see me do most of the time is I'll come up through here like this, and I'll put a 1. So natural log of 3 plus natural log of x minus 2 is the answer. Questions? Now, what's going to be the thing that's going to cause us the most trouble here? That's stinking square root, right? Because this is really the natural log of x squared y over z to what power? 1/2. So the first thing we look at is, I'll put a separator in there. First thing we look at is that a quotient turns into a what? Subtraction. So natural log of x squared y, I almost took a shortcut, minus the natural log of z to the 1/2. This is a product. A product turns into a addition. So natural log of x squared plus natural log of y minus natural log of z to the 1/2. Now what do I need to do yet? Bring the exponents down to natural log x plus natural log y minus natural log 1/2 natural log of z. Write an expression as a single logarithm. Assume all variable expressions within the logarithm represent positive numbers. It has everything to do with the domain. So what's the first thing I have to do?
Take the exponents back.
Take the exponents back home, right? So this becomes the natural log of 17 minus the natural log of y squared, 17 to the 1/4, natural log of y squared, minus the natural log of e to the x. Now these stinky people put natural log of e to the x. What's natural log of e to the x? Just x. Just x. So if I take a look at natural log of e to the x, this is x natural log of e. If I bring the exponent down, natural log of e is 1. This is just x. Icky people. However, do we necessarily see that all the time? No, we envision it. So what's these two turn into? Division, right? (17 to the 1/4) divided by y squared minus, this is what makes things ugly. Because if I don't see it, where does the e to the x go? No, here it is, right here. Where it's, here I have something times the natural log of e to the x. Now if I want to bring it in and make it a single logarithm, where does this guy go? I have to put it on the bottom. Why do I have to put it on the bottom? Because there's a subtraction. And then you're going to look in the back of the book and you're going to say, that's not the answer they got. Is that a correct answer?
Yeah.
Yes. It's just not their answer. Because what they did is they said, okay, so now what you have is the natural log of 17 to the 1/4 divided by y squared, and they probably wrote that as a radical, and then minus the natural log of e to the x. And then they said, oh, natural log of e to the x is really just x. And then you're going to look at that and say, where did that come from? Well, now we know it's because it's the natural log of e to the x. Anytime you have natural log of e anything, you can usually get rid of it.